Okay, it starts off with our crew patch. I helped, was in charge of designing it. The whole crew put in their efforts. And you have the Earth and the space shuttle, and we've got the little triangle there that represents the Cmdr satellite, the shuttle, and the MCC here on the ground. And it has a red, white, and blue of our flag. And also for people from Ohio, if you look around the edge of it, it's in the shape of an O because this was the old Buckeye crew.
I think most of you are aware we were delayed from our first launch due to this pesky rascal down at the Cape. However, our hats were off to the technicians there at the Cape who repaired the ET and successfully rolled back out for an on-time launch June 22nd. Here we are suiting up in the room. That's Kevin Kregel, the pilot. Dr. Don Thomas, Mission Specialist 1. Army Major Nancy Currie, Mission Specialist number 2, and Dr. Mary Ellen Weber, Mission Specialist number 3. Of course, it was a glorious morning, as most mornings are at the Kennedy Space Center. As you know, we wake up about 6 hours before launch, have our breakfast, put the suits on, and then go out for our final chance to wave goodbye to all the folks who supported us up to this point as we walk out to the Astrovan. And that was the Buckeye that flew along with us that I showed to the press at that point. And we would like to thank all the support around the country, and especially that from Ohio, which was outstanding.
We're getting ready to launch on the pad. This is also the first flight of the Block 1 engine. The Block 1 engine takes a number of wells out of the oxidizer turbo pump from a little over 200 to about a dozen. So it really helps with the reliability. From inside the cockpit and our engine parameters, it was absolutely no difference, and it worked flawlessly. We're getting ready for the fire suppression and the water suppression to light, and off we go. They always have the rookies say what it was like for your first launch. And of course, once those solids light, it really is a kick in the pants, and you know that you're going to go someplace. And it's shaking a bunch, but it really wasn't too bad. And thanks to all the people around here, except for the G-forces, it felt like I was back in the simulator. And I was back in the simulator looking at all the switches, except you could feel the G-forces, and as most of you know, it goes up to around 3 Gs for the last 2 minutes of launch. And that's really the only difference. You'll see as we go through the supersonic today, that on the day of launch, we had the right atmospheric conditions to show the shock wave coming over the orbiter. And it really made it for a spectacular launch, just coming right over the SRBs and across to the shuttle. And of course, after about 8.5 minutes, everything worked just fine. Beautiful day, and we're getting ready to do what we're sent up there, and that's to launch the Cmdr satellite.
It's a busy first day for us on orbit. As soon as we get up to orbit after 8.5 minutes, we start getting out of our suits, taking our seats down, and getting ready for the satellite deploy. About 2 hours into the mission is actually when we start checking out the Cmdr satellite here. This is the 6th and final tracking and data relay satellite that will be launched from the shuttle. The very first one was on STS 6, and this is quite a tradition. This shows all the crew members here at the aft panel. We're looking up towards the back of the payload bay and watching the Cmdr as it raises up, and here we're about ready to punch it out. It moves out very slowly here, just a few feet a minute, and it went so smoothly and nominally on orbit. It was unlike any of our simulations where our training team throws all the malfunctions at us, and it just went so perfectly like clockwork. This is 6 hours into the mission as it's moving out. The top half of the satellite that you see is the tracking and data relay satellite itself, and the bottom half is the inertial upper stage, which is a 2-stage solid rocket motor that'll take the satellite from 160 miles here out to geosynchronous orbit about 22,000 miles out. And as you can imagine, our noses were pressed up against the windows pretty much looking at this, except for Nancy trying to get a good picture with the camera here. And that was just a great feeling to have it go out right on time, nice and smooth. Shows the satellite there in the distance as it's moving off, and we started to back away from it with the orbiter, and it's currently out at geosynchronous orbit. They're continuing to check out of the satellite, and everything's going great with it so far.
This is a dedication of the plaque for the new Mission Control Center. As y'all probably know here, that we were the first flight that was controlled out of the new CCC, or Combined Control Center, which will be used for combined shuttle to Mir and shuttle station missions. And from the crew's perspective, it was totally transparent, which was just exceptional. This is the morning of flight day 2. We start picking up with the meat of our flight plan after the successful deployment of TDRS. For all the principal investigators, you can see that we diligently reviewed our messages in the morning, coming off the tips. And this kind of shows a little bit about our daily routine. This is Don taking his equivalent of a shower in the morning. You can't ever escape the watchful eye of other crew members or the camera. And this is floating over to the galley. You know, all of us like to do stupid astronaut tricks and so forth on orbit. And you'll see our equivalent of that here shortly. We really didn't play too much. Kevin's trying his hardest to form a ball of juice here, but he found out very quickly he better have a towel handy when he's trying this. And this displays my unique eating habits. This is creamed spinach, which I ate for breakfast every morning, so they felt like they needed to get that on film. And this is Don on the ergometer. You can see kind of hamming it up a little bit here. Although he was working pretty hard, I can assure you. And we all had the time to exercise. We were all in really good shape at the end of the flight.
This is the bioreactor experiment. It's one of the, I think, most exciting experiments on our flight. What they're trying to do is actually grow three-dimensional body-like tissues outside the human body. It's something that's very difficult to do here on the ground under the influence of gravity. The experiment worked extremely well. They got very large-size tissues. You can see inside the chamber right there. And this was the first flight of this configuration. And the hope here is that one day we might be growing replacement organs and really understand how tissues actually grow.
This is an experiment conducted with the National Institutes of Health, NIHR. We flew 10 pregnant rodents, and we were looking at musculoskeletal development changes in microgravity.
This is an amateur radio experiment called SAREX that we flew on board. We talked to a total of 8 schools, mostly in the United States, but we did talk to one in Argentina. And that was a great thrill for these 8-minute passes to be able to talk and share the excitement of spaceflight with many students around the world.
This is an experiment called the Space Tissue Loss Experiment, looking at the development of Medaka fish embryos. Again, we're looking at embryonic development and microgravity. This is an interior view. This is near the end of the flight. You can actually see the blood flow through the embryo. And actually, they saw quite a significant difference between our downlink video of those developed in microgravity versus the ground-controlled studies. This is one of the cameras that we flew. It's a multispectral imaging camera. It's looking at thruster plumes and also water dumps. This is an example looking out the side hatch of a water dump with a Windex camera. And next you'll see a thruster firing that was filmed out the aft window. We did a series of primary jet thruster firings. And they're looking at the chemistry and physics of the emissions from the shuttle on not only the shuttle but also other orbiting structures.
Another experiment we flew was again using a multispectral camera. And this is called Hercules. It's a pretty big beast. It weighs around 70, 80 pounds. And here on Earth, we had to actually rig up a tripod to practice using it at all. But we actually had 2 of us using it to aim because it's like looking through a soda straw. And we're looking at targets on the ground. And the big bump on the top of the camera is an inertial measurement unit. And the hope is that we can accurately look at places on the ground and also be able to look at the latitude and longitude. Here you see a picture of Guantanamo Bay, Cuba, and you can see pretty good resolution. It's jumping around there, so real time it's a little bit tough, but it's going 30 frames a second, so post-flight people on the ground can really look at it pretty well. And this is a picture of a city at night. It's totally dark out for us in Australia. So the Hercules has a lot of potential and had a lot of couple of problems in the beginning, but through the hard work of people here on the ground, we got it to work.
And this is an experiment called the visual function tester. As you know, when you take away gravity, some pretty dramatic changes happen in the human body, and one of those changes is that the eyeball shape actually changes and the vision is affected.
This is a picture of Hurricane Chantal, which is forming in the Atlantic. Luckily, it didn't hit land, it turned north, but we got a good view of this on flight day 2 and 3, passed almost directly over top of it.
This is passing over Egypt. You can see the Nile River there in the lower left and coming up on the Red Sea. This is a beautiful pass always because you have the very light brown soil and the blue water there. And one morning, shortly after our wake-up music, somebody peeked out and said, hey, we're going right over Egypt and the Nile River, and you should see us all scrambling, getting up as fast as possible and getting our noses up to the window there. But it's a spectacular pass, and this is one of our great entertainment mechanisms up on orbit, is just to look out the window and watch the world go around.
We were proud of this shot. There was actually 3 planets in this view. And of course, you can see something similar to this right before sunrise on Earth. This is Venus and Mars coming up just before sunrise. The advantage we had being in the orbiter was that we could set the cameras up on 1 rev and an hour and a half later actually take the scene. Happened very quickly, but again, we thought it was a spectacular shot and took the time to capture it on 16mm film. You never get tired of looking out the window, as Don's emphasized. And you can see the orbiter tail and OMS pods in the upper right-hand corner.
This is, again, looking out the window even at night is spectacular. This is over Asia and the Pacific, and you can see the Earth glow, which I'd never really noticed in pictures before, and it's real evident on how tenuous our atmosphere is. And looking at the lightning storms, literally for hundreds and 1,000 miles, you can see the lightning going off, and you can see how it propagates all across the continent, all across the ocean. It's really a real pretty view. And unfortunately, the day before we're supposed to come back, they tell us it's time to quit having fun. And so we do all the checkouts. We're checking out the reaction control jets. We're checking out the auxiliary power unit, getting ready to come back home. And this flight was really, it was flawless. They say flawless for all the missions, but our biggest problem we had was a cut in a vacuum cleaner cord. It was really a very clean orbiter. All the experiments were in really smooth. We're closing the payload bay, getting ready to come back home. It was kind of nice, actually, that we got to close the payload bay twice, because it meant we had a couple more hours on orbit when we got waved off the first day.
Here we are in entry. Again, as Kevin mentioned, we waved off the first day's attempt. And here we are on the morning of July 22nd. At the entry interface there, we're going approximately Mach 25, and you saw the plasma jet out the overhead window. We came across the southern Texas coast, and some folks mentioned hearing us and seeing us go by that morning. Here we are making the heading alignment cone turn and rolling out on final. Again, I think most of you are aware we're diving at 20 degrees, 300 knots. We had light winds that day, lots of moisture in the air, so you see the condensation coming off the wingtip vortices there. Kevin put the gear down at 300 feet. Again, very responsive machine. The shuttle training aircraft was an excellent trainer. We followed our guidance and all our training procedures and ended up with some excellent touchdown numbers on this flight. Kevin deploys the drag chute just after main gear touchdown. We derotate using what we call the beep trim method now, and then the drag chute blossoms about nose gear touchdown. We apply the brakes, very smooth and positive braking, and come to a stop about 11,000 feet down the runway at the Kennedy Space Center. And the story wasn't over at this point. We mentioned that we thought we were exercising right, we were eating right. We also slept very well, so we had an excellent crew status at wheel stop. We stepped through our post-flight activities very quickly in the orbiter and set a record 30-some minutes for getting out of the vehicle, and everyone was so healthy that they were willing to walk around the vehicle, and we all felt great after the flight, and that's a compliment to all the folks here that have worked so hard on all the countermeasures for readaptation to one. To the technicians there at the Cape who repaired the ET and successfully rolled back out for an on-time launch June 22nd. Here we are suiting up in the room. That's Kevin Kregel, the pilot. Dr. Don Thomas, Mission Specialist 1. And then go out for our final chance to wave goodbye to all the folks who supported us up to this point as we walk out to the Astrovan. And that was a Buckeye that flew along with us that I showed to the press at that point. And we would like to thank all the support around the country, and especially that from Ohio, which was outstanding.
Okay, it starts off with our crew patch. I helped, was in charge of designing it. The whole crew put in their efforts. And you have the Earth and the space shuttle, and we've got the little triangle there that represents the Cmdr satellite, the shuttle.
Army Major Nancy Currie, Mission Specialist number 2, and Dr. Mary Ellen Weber, Mission Specialist number 3. Of course, it was a glorious morning, as most mornings are at the Kennedy Space Center. As you know, we wake up about 6 hours before launch, have our breakfast, put the suits on.
And the MCC here on the ground, and it has a red, white, and blue of our flag. And also for the people from Ohio, if you look around the edge of it, it's in the shape of an O because this was the old Buckeye crew.
I think most of you are aware we were delayed from our first launch due to this pesky rascal down at the Cape. However, our hats were off.